I determine probability for a particular value of a random variable, discrete random variable. What's an example of a discrete random variable? How many brothers and sisters do you have? How many cars you own? How many classes you take? How many surgeries you have in your lifetime? All those would be examples of discrete random variables, right? They're countable. Okay, 1, 2, 3, 4, 5, something like that. They're discrete integer values that are countable. Okay? Continuous. A lot of things are continuous. How much money you make, how long you live, your height, your weight, your age, all those would be examples of continuous. Why is that? Because you can never get quite a precise answer. You can live, another millisecond, and after a millisecond, another nanosecond, and after that, another Uranus second, and after that, another Venus second, etc. So you keep going more. I'm making that. As long as anybody wants to say that. So you just keep going more and more and more. Okay? All right. Probability distribution for the number of television sets per home is given below. 0.04, 1.27, 2.55, 3.12, and 4.02. So 0.04, 1.27, 2.55, 3.12, and 4.02. This is X. This is the probability of X. The question is it a probability distribution? Is that a probability distribution? How do we know? Well, it must have two characteristics, and only two. The probability of each one of those must be between what? 0 and 1. The probability of having no TVs must be between 0 and 1. One TV between 0 and 1. They are all somewhere between 0 and 1. And secondly, they must what? They must sum to 1.0. Do they? 4 and 27 is 31, 86, 96, 98. They sum to exactly 1. They sum to exactly 1. Is the random variable number of TVs discrete or continuous? Clearly discrete. How many TVs would you expect a family to have in their home? It's not 3. It's not 2. It's not the one with the greatest probability. Okay? That's different than how many you would expect. You have to figure out the mean or the expected value of this distribution. Okay? We can do that one of two ways, the hard way or the easy way. Okay? We can plug these into list 1 and these into list 2. Okay, if we do that, we go one variable stats, L1, L2, that gives it to us directly. Or we can do it the hard way. Hard way is we find the mean or the expected value of X by the summation of X times its probability. In this case, that would be 0 times 0.04 plus 1 times 0.27 plus 2 times 0.55 plus 3 times 0.12 plus 4 times 0.02. This goes to 0. This gives me 0.27, 1.1, 0.36, 0.08. And that gives me 1.81. You want to check it using the other way?
I did.
I beat you? Did you beat me?
It was like same time.
About the same? You really kill me now, though. It's the standard deviation. So, okay? Standard deviation. Square root of each individual value squared times its probability, right? Minus that mean quantity squared. So in this case, this would be the square root of 0 squared times 0.04 plus 1 squared times 0.27 plus 2 squared times 0.55 plus 3 squared times 0.12 plus 4 squared times 0.02 minus 1.81. Okay? So it's painful. 1 squared is 1. That'd be 0.27 plus 4. 2 squared is 4. 4 times 0.55, 2.2. 3 squared is 9. 9 times 0.12 is 1.08. 4 squared is 16. 16 times 0.02 is 0.32. Minus 1.81 quantity squared. So when I add this up, I get the square root of 3. Is that right? 3.87 when you add all that up? Did I add it right?
What EX2 is.
So is that right? 3.87 when you add all this up? And what's 1.81 squared? What's 1.8 times 1.8?
3.27.
3.27. I subtract those, I get the square root of 0.6, and that's equal to what? 0.77. Is that what the calculator gave you for the standard deviation? Hey, it works. All right, is everyone okay with that? So you can work in one of 2 ways. Yeah, the first one is the standard deviation. This is the mean or the expected value. They are indeed the same.
On your calculator, you're looking for the mean. The mean would be the expected.
Yes, they're the same. And the standard deviation is also there. And you want to pull up sigma, not S.
What if S doesn't come up?
Did it not come up?
They only gave me.
Sigma. Okay, good. I know. All right. Find the probability that a family has at least 1 TV in their home. At least 1 TV. So that would be this. All those would be at least 1 TV, right? So if you had 4, you got at least 1. If you had 3, you got at least 1. If you got 1, you got at least 1. So that would be the probability of at least 1 TV equal 0.96, right? I add all those up. Okay, now I add 0.96. Well, clearly that's a complement of what? None. Having no TVs, 0.04, 1 minus that would be more than no TVs. Okay, is everyone okay with that? Suppose a 5-mile race times have an average runner's finish time of 42 minutes with a standard deviation of 6.5. If 500 people run, at least how many will have finish times within 2 standard deviations of the mean?